All right, so the first thing is the general equation of a line in algebra is y is equal to mx plus b. You should remember this from a long time ago. Now, when we have this guy, I need to point out a few things. The independent variable is the x variable. The dependent variable is the y variable. The m term and the b term, those are just numbers. So m is a number and b is a number. Now, the m is actually what we call the slope of the line, and we're going to graph one here in just a second. I'll remind you what that is. And then the b here is what we call the y-intercept. So I'm going to abbreviate that y-int. That's the y-intercept. So here in a minute, I'm going to show you how to graph any line that you have by just knowing its slope and its y-intercept. We're going to do that in just a second. But before we get there, let's take an example of a real line and graph it just by plotting its points. So we're going to crawl before we can walk. So let's say we have an example. Y is equal to 2x plus 1. Now first you should be able to immediately know that this is a line. This is definitely a line. Why? Because it falls into the exact form of what I've written here. Y is right here. Mx plus b. M is 2. X plus b. B is 1. So you already know from looking at this, that whatever number is in front of the x variable is automatically the slope of this line. It's basically going to be the steepness of this line. Steep lines go like this, shallow lines go more like this. We're going to get to that here in just a second. So that number is governed by whatever's in front of the x variable. We call it m. And then we have b, which is y-intercept. We'll talk about what that means in just a second whenever we plot this line. Now you can graph this line just by knowing its equation, but to crawl before we can walk, let's do it by plotting points. So let's make a table of x values, right? And then we're going to plug in the value of x values, and then we're going to come up with the y values. Y is equal to 2x plus 1. So this is how you would plot this equation of this line just by knowing its points, by actually just plotting a few points. So we need to pick some random points for x, and then we'll stick them into this equation. We'll calculate the value for y, and we'll have a bunch of points. So let's take negative 2 because we want some negative values. Negative 1, getting close to 0, which is right there. And then let's take 1, 2, and 3. So really you only need 2 points to graph a line. Any 2 points you can define a line, but just to show you how we're doing it, we're going to graph all of these points, or use all of these points. Now for every one of these x values, all you do is you stick it in here and calculate the corresponding y value. So for this value, it would be y equals 2 times x, but x is negative 2, plus 1. Right? So negative 2 times negative 2 right here gives you negative 4. You still have to add the 1 to it. Negative 4 plus a positive 1 is negative 3. This is all algebra. So how to multiply negative and positive numbers, how to add these negative and positive numbers. If you're unfamiliar with that, if it looks completely foreign to you, then you really need to go back to do some basic algebra. And you can go back to my algebra topics for that. But for here, I'm going to assume that you know how to do this multiplication and this addition because you're a little farther along. All right, the next point, y is equal to 2 times x, but x in this case we're saying let's pick negative 1 plus 1, so 2 times negative 1 is negative 2 plus the positive 1. When you add those together you get negative 1. So once you get the hang of this, it's pretty simple. 2 times 0 plus 1 is 0 plus 1, which is positive 1. And then we'll put the next one in. 2 times x is equal to positive 1 plus 1 is going to give me 2 plus 1, which is equal to 3. And then we'll plug this value in. 2 times 2 plus 1 is 4 plus 1, positive 4 plus 1 in this case, which is going to give me 5. And then the last one, 2 times 3 plus 1 is going to be 6 plus 1, which is 7. Okay, now why did we do that? We could have only chosen a couple of points, but you'll see why I chose a few more here in just a second. Okay, so now we have pairs of values. We have the x corresponding to this value of y. We have x is equal to negative 1 corresponding to this, and so on. X comma y, and so on. So now we can plot these points. So let's go ahead and do that. Negative 2 comma negative 3. Negative 2 for x is right here. This is negative 2. Then we go down, negative 1, 2, 3. So this point is right here. So negative 1, 2, negative 1, 2, 3. I'll put a dot right there to signify that first point. Now we look at this one, negative 1 comma negative 1. So x is negative 1, which is over here, and y is also negative 1, which is right here. So negative 1 comma negative 1 is right there. Now, just so you know, you already have enough information to graph this line. All you have to do is get a straight edge and go through there, but it's oftentimes good to have a couple other points just to make sure that you didn't make a mistake. So we have 0, comma, positive 1. 0, comma, positive 1's right here. Notice that all of these points continue to look like they fall on a line, which they should. 1, comma, positive 3. 1, comma, 1, 2, 3 is up here. And then we have 2, comma, 5, which is, here's 1, 2, comma, 1, 2, 3, 4, 5 right there. So 2, comma, 5 is going to be here. And then our last point that we have on this line is 3, comma, 7. So it's going to be 3, comma, here's 5, 6, 7. So that last point is right up there. 3, comma, 5, 6, 7 is right there. Now, from eyeballing it, it obviously looks like these all fall in a straight line. So just take a second to grab your straight edge like I'm going to do and just draw a line that goes through all those points. Now again, don't forget why we're doing this, because we're going to be doing regression analysis in a minute. We're going to have a bunch of data points and we're going to be finding the best line that goes through them. Now when you calculate the line, you're going to be given an equation like this. You're going to calculate the slope and the y-intercept here, which I'll explain more about in just a minute, but you're going to get this equation of a line. This line is going to be going through all of your sample data that you have. But for now, I want to show you and teach you all about lines. So we took our line, we made up a bunch of random x values. We could have picked any x values we wanted, and we calculate the corresponding y values. We plot them, and we see that they're all on a line. Okay, so that's how you graph a line. No, one way to graph a line. The easier way to graph a line is just to look at the equation and know that this is the slope and this is the y-intercept. Now first, I want to turn your attention to this thing called the y-intercept, which is basically the y-intercept is this value of 1 right there. The y-intercept is the place where this line crosses the y-axis. Remember, this over here is the x-axis, and this over here is the y-axis. So wherever the line crosses the y-axis is what's called the y-intercept. That makes sense, right? It's intercepting the y-axis. Notice it crosses right here at y is equal to 1, which is what we're saying here. So the y-intercept, we can just write down, you can say the y-intercept for this line is at y is equal to 1. And that you just read it straight off of there. So by knowing any equation of a line, when you write it in this form, you just take the number that's over here, you stick a dot right there, y is equal to 1, and you know that the line crosses through this point just by knowing that one piece of information. Now, without examining further, you don't know if the line goes through like this, or if the line goes through like this, or if the line goes through like this. You see, there's many lines, actually infinity lines, infinite ways in which I can draw a line through that point. So you need another piece of information to graph the line. And that other piece of information is called the slope. All right, so in this case, the slope, which we call m, in this case is 2. Now the thing you need to remember from algebra, because it's probably been a long time, the slope is what we call rise of the line, how far the line goes up, divided by the run of the line, which is how far the line goes over. So rise is how far this line goes up, run is how far this line moves over to the right. And we divide those two things, and in this case it just happens to be 2. Now the number 2 is 2 over 1, right? So you can write the slope as 2 over 1. That's exactly the same thing as 2. So what you're really saying is that this line has a rise of 2 and a run of 1. Okay, so you always want to write your slope as a fraction to recognize its rise over run. So the way that you kind of can graph this without drawing all of these points and going through all this math is just look at the y-intercept, stick a dot where the y-intercept is, and start from this dot and recognize that this line rises 2 units up to the top, upwards, and runs over to the right 1 unit. So the ratio is up 2 over 1, up 2 over 1. Notice we start from this point, it's up 2 over 1, up 2 over 1, up 2 over 1. And if you can keep going forever, up 2 over 1. Even if you start down here at this point, up 2 over 1, up 2 over 1. You see how the slope basically can give you as many additional points as you want. So you start here, you put a dot, you go up 2 over 1. Put another dot, then you have your line. All right, so this line has a positive slope, and you will learn here in a second that positive slope means it slants up and to the right, and the bigger the slope means the higher the rise compared to its run. So the bigger the slope that you have, the larger the number, the steeper this line is going to be. If you have a very small slope, it's going to be just like a mountain. If you say a mountain has a small slope, then it's a small number, and this line is going to be flatter looking. But if this slope is big, if this slope is 10 or 20 or 50, or if this slope is 1,000, then you're going to have a really, really steep line because you mean a very high rise compared to a very small run over to the right. So that's all I want to get across here. Let's go and do another one of these guys, and then we'll compare and contrast the differences. So this was just one line I gave you where you could read the slope of 2 and a y-intercept of 1, and I showed you how to graph that. Now let's go down here and do it again for a couple of additional examples. Let's say we have a line that's y equals 3x minus 2. So here's a separate line. Remember, what did I tell you? I said the slope is going to be whatever is in front of the x, and the y-intercept is going to be here. Now before we get to that, let's just do it the old-fashioned way and say, well, let's get some practice with making this table. We'll pick some x values and we'll pick some y values. In this case, y is 3x minus 2. Now, since we know they're all going to be on a line, and since we've done that one example, I'm only going to pick 3 points, -1, 0, and +1. For x. I could pick any numbers I want for x. I could pick 5, 10, 15. I could pick -2, +3, -1/2. It doesn't matter. I'll stick these numbers in here and calculate the value of y. So what we have here is, for this one, y is equal to 3 times x, which is -1 minus 2. What's 3 times -1? It's -3 minus 2, -5. That's the final answer. And then we'll do the next one. Y is equal to 3 times x, but x in this case is 0 minus 2, so we have 0 minus 2, -2. And then the last one, y is equal to 3 times 1 minus 2, which is 3 minus 2, which is +1. So you now have pairs of points, -1 for x, +5 for y, 0 for x, -2 for y, and so on. So let's plot those 3 points. -1, -5. So we go over to the left, -1, which is here, and then we go -5, which is way down here. So -1, -5 is actually way down here. The next point is 0, -2. 0, -1, 2 would be right there, so we put this point right here. And then the final one we have is 1, 1. So we go over to the right of +1, up here, +1 right there. Notice that these points all look like they lie on a line, which is what you should always have, obviously. So you really only need 2 points, but I just pick a third one usually just to make sure I didn't make a mistake. Because if they all fall in a straight line, then you know you haven't made any mistakes, or at least you think you haven't made any mistakes. So that's the equation of that line. Now, a couple of things I wanted to point out. What is the slope of this line just by looking at its equation? The number 3. Remember, the number 3 is whatever's in front of x. That's what we call the slope. So let me write that over here. The slope is equal to 3, which is equal to 3 over 1, right? That's how you write that as a fraction, which is rise over run. Right? So a couple things I want to point out. Notice when we go back to that original graph we had a minute ago, we had a slope of 2. The slope was 2 here, so 2 is obviously less than 3. So this line looked like this because its slope was 2. Now we come down here, we're saying this line has a slope of 3, which means it's a steeper line. And if you compare these, this is actually a steeper line than the one that we looked at. So the bigger the number that you get for the slope, the steeper the line is. Notice it's also a positive slope. Positive lines always go up and to the right like this. It's just steeper and steeper and steeper the higher the slope that you have. Okay. Now, how do you find the y-intercept? The y-intercept is -2. So where am I going to write that? I'll put it right here. The y-intercept is -2, right? Is that correct? Is that where this crosses the y-axis? Well, we go down here, -2. Yep, this line crosses exactly at y is equal to -2. So the y-intercept is here, so you could graph this line without using all these points by just saying, hey, give me the y-intercept, go down here to -2, put a dot. The slope is 3, which means rise 3, run of 1. So up 3 over 1, up 3 over 1. So we start at this point, up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. You see how you're always going to get as many points as you need by knowing the y-intercept gives you 1 point and then going up 3 over 1 or whatever the slope happens to be. So that's how you would graph this without using the points. But again, the bigger the slope, the bigger the number, the steeper the line, and because it's positive, it's always slanting up and to the right. Now, we're going to do another problem. This time we're not going to draw these points. We're just going to graph it by using the slope and the y-intercept. So -x plus 2. This is a different line. Okay, now let me ask you, we could do a table of values. We could choose x values, calculate the y values, plot the points, and get the line. Of course we could do that. Now we're going to use our knowledge. What is the slope of this line? The slope is whatever's in front of x. What do you see there? You see a negative sign. So a lot of students say, well, what does that mean? Well, that means that the slope is just -1 because that's what's in front of x, -1. How do you write -1 as a fraction? You write it as -1 over 1, right? Which is the rise over the run. Now, it's a little bit weird that you have a negative number up here. I'll give you that. So we'll come back to that for just a second. But that's what the slope is. Now, what's the y-intercept? That's this number here, the only other number that's present. So the y-intercept is just equal to 2, +2. So what does this y-intercept means? It means this line, whatever it looks like, crosses at y is equal to +2. Here's y is 1, here's y is +2. So we can just immediately put a dot right here. We know the line crosses here. But what we don't know yet is, does the line look like this? Does it look like this? Does it look like this? Does it look like this? We know it goes through that point because the y-intercept tells us that. But now we look at the other piece of information, the slope. It's -1, which is a negative rise over a positive run. So over in this example, we had a positive rise, which means we go up 3 over 1, up 3 over 1. But since this is a negative rise, it means you start from this point and you go down 1. But the run is still positive. So you go down 1 and then over to the right 1, down 1, over to the right 1, and so on. So since we go down 1 over 1, we can put our second point immediately right here. And now we have enough information. We don't need any more points to draw a line. We can just draw a line through these two. You can get more if you like. That's totally no problem. But that's how you draw that line. And you see, you don't have to get this table of values or calculate all this stuff. All you need to do is look at the y-intercept, stick a dot there, look at the slope. If it's a positive slope, you go up and over. If it's a negative slope, you go down and over. Now, a couple of things. Notice that negative slope slanted the line catty-corner totally the other way. So any slope with any line with a positive slope is going to go up and to the right. Any line with a negative slope is going to go down and to the right. So that's all you have to remember. Positive slope lines look like this. Negative slope lines look like this. All right, that's about all I really wanted to say here. It's really important for you to understand what an equation of a line looks like, that the negative slope lines look like this, the positive slope lines look like this, and of course, the smaller the slope, in this case, this was a slightly smaller slope than the one over there, the shallower that line. If you get to lines that look like this, you're going to have very small slopes because they have small slopes, right? Now you can graph the line by points. You can graph it by using its slope and its y-intercept. That's about all I wanted to review with you. Make sure you understand this. If you're still completely lost on this, then go back to my algebra lessons, and there's a lot more examples. Go back there and really understand it, because here in just a minute we're going to be drawing regression lines through a bunch of data points, and you need to know what these lines look like and how to graph them so that you know what you're doing. That's why I wanted to review this here. So make sure you understand this, follow me on to the next lesson, and we'll do that right now.
Learn anything at mathandscience.com.